This is a Beautiful Mars podcast for Friday, February 10th, 2017, from HIRISE on board NASA's Mars Reconnaissance Orbiter. This week, it's all about impact craters, so let's get started. The dark spots in this enhanced color infrared image are the recent impact craters that occurred in the Tharsis region between 2008 and 2014. These impact craters were first discovered by the Mars Context Camera as a cluster of dark spots. The meteoroid that formed these craters must have broken up upon atmospheric entry and fragmented into two larger masses, along with several smaller fragments, spawning at least 20 or so smaller impact craters. The dark halos around the resulting impact craters are a combination of the light-toned dust being cleared from the impact event and the deposition of the underlying dark-toned materials as crater ejecta. This distribution and the pattern of the rate ejecta suggests that the meteoroid most likely struck from the south. This is the first image of this particular impact taken by HIRISE, thanks to a request by the Context Camera team. This image reveals an impact crater, 9 kilometers in diameter, with a central peak. Impact craters of various sizes and ages can be found across the Martian surface. Like the impact of a droplet into fluid, once an impact has occurred on the surface of Mars, an ejecta curtain forms immediately after, contributing to the raised rim visible at the top of the crater's walls. After the formation of the initial crater, if it is large enough, then a central peak appears as the surface rebounds. These central peaks can expose rocks that were previously deeply buried beneath the Martian surface. The blue and red colors in this enhanced contrast image reflect the effects of post-impact sedimentation and weathering over time. Mars is a dynamic planet. HIRISE has witnessed many surface changes over the past 10 years, including hundreds of new craters formed by ongoing impacts. Most of these impacts are likely caused by asteroids that have strayed into collision courses with Mars. This new crater, which formed explosively at the point of impact, has a diameter of roughly 8 meters, but its surrounding blast zone and ejecta extend over a kilometer, about 1 mile beyond the crater itself. The materials exposed nearest the crater have distinctive yellowish and lighter gray appearances, while more distant ejected materials range from dark brown to bright bluish in an enhanced color view. These varied materials may have originated from different layers penetrated by the impact. This new impact was discovered using the lower resolution context camera. An older context camera image of this region from May 2012 shows a uniformly dust-covered surface, while a newer one from September 2016 reveals the crater's dark blast zone. New craters on Mars are easiest to locate in such dust-coated terrains, where they provide opportunistic road cuts that allow scientists to see beneath the dust blanket and determine the underlying rock compositions and textures. The broader scene for this image is the fluidized ejecta from Bakusan crater to the southwest. But there's something very interesting going on here, on a much smaller scale. A small impact crater, about 25 meters in diameter, with a gouged-out trench extends to the south. The ejecta, the rocky material ejected from the crater, mostly extends to the east and west of the crater. This butterfly ejecta is very common for craters formed at low impact angles. Taken together, these observations suggest that the crater-forming impactor came in at a low angle from the north, hit the ground, and ejected material to the sides. The top of the impactor may have sheared off, effectively decapitating the impactor, and continued downrange, forming the trench. We can't prove that's what happened, but this explanation is consistent with the observations. You can see these images and more at uahirise.org.